This week we're going to talk about data. Where do we get it and what do we do with it? Well, first, what are we even talking about? What is our data? Data is just whatever you have gathered. And when we talk about data versus observations, data are observations that are gathered in a systematic manner, or information we have collected. So I might make an observation that might be casual or not necessarily planned. Data are gathered in a planned, organized fashion. Data don't have to be numbers. We often think about that as numbers, but it can take lots of forms. It can be numeric or non-numeric. So what kinds of data can you see? In a lot of different kinds of research, we use different kinds of data. For instance, sometimes we use texts or simply documents, and we might review the words that are in them. We might do observations. I might go out and I might watch what people do in a public setting, and I will document the instances of observations that I was looking for. I can engage in self-reports or other reports, and that means that I can simply ask you how you are thinking or feeling about a subject, and I can ask others how they think you are thinking or feeling about a subject. And sometimes gathering those two pieces of information can be quite interesting, because you might think that you are a very kind and considerate person, and everyone else thinks you're a bit of a jerk. So sometimes our own self-reports can, we look at ourselves through rosy-colored glasses at times. So what do we do to gather our data? In general, what we do is something called sampling. And sampling is where we just get a little bit of some population that we are looking at. And so it is just a sample, right? Just like if you were to go to a grocery store and they were giving out free samples. You don't have to eat the entire pizza to know what the pizza tastes like, but if they give you a little bite, you have a good idea of what the pizza is going to be like. That's what we're doing with our sample. I want to know what the population is going to be like, and so I go get a little bit of it and I look at it. Why do we do that? Well, if we get a sample that is representative of the population, then we are able to make claims about the population. So if I want to know what this pizza is going to taste like, I've had a piece of it, I have a pretty good idea of what the rest of the pizza is going to be like, as long as I can see that there's nothing strange happening on the pizza. It all seems to look the same, it was prepared the same way, and why I gathered that piece, there's no real rhyme or reason, it could have been any of them, then yeah, the whole pizza is going to be pretty much the same as the piece that I had, and that's what we want to attempt to accomplish with our sampling. We want our sample to tell us something about the population, because our sample is representative of the population. Now, why do we rely on samples instead of the population? Well, one, it's hard to get a whole population. If we're talking about voters, for instance, that's millions of people. I can't get them all together and ask them a question. So often we rely on sampling to get a sense of what they're going to do. And one of the things that allows us to do that is something called the central limit theorem. It sounds complicated, but really all it means is that when I gather a sample from a population, that sample will start to look normally distributed. And what that means is, you can see on the bottom of this image that I have here, there's what we refer to as a bell curve. It is a nice looking curve. It looks like a nice bell, right? Hence the shape. That's what we expect populations to look like. Most of the people are in the middle. There's a couple people on the extremes, so on the left side of it and on the right side of it. Most of the people are in the middle. But if we gather enough samples, we're going to find that sometimes they don't look like that. So you can see X1, 2, 3, 4, and 5 up there. They don't all look like that pretty little picture at the bottom. But if we gather enough samples across them, as we get a larger sample, it tends to look like that normal distribution. And so when we reach a minimum of, say, 30, we tend to see our sample normalize. In other words, we have collected enough people who tend to be in the middle and a little bit of the people who are on the outsides of it. And so we can randomly select people from a population, and then we can find something that's going to look like and be representative of the population. Now, if we don't randomly sample from our population, sometimes our error can be higher, and it's going to look like the weird triangle thing up top there instead of our nice bell curve. Sometimes random sampling doesn't work out for us, that we can just, randomly pull people out of millions and we have something that's representative. And so a lot of times we do have to rely on these non-random sampling techniques. One of them is just the convenience sample, and you're probably familiar with this if you've ever participated in a survey that someone was doing. You are conveniently located. It's easy to find people at a university who need extra credit in a class to fill out a survey. So you are convenient. Do you represent the entire population we're talking about? No. Are you convenient? Yes, and so we go with that. There's also something called snowball sampling, in which I ask you to provide me with names of people who are in the population I'm looking for. Sometimes this is used if it's difficult to track down who might be in that population. And so if I have sort of access through a couple of people, I will ask you to get me further access to that population. Sometimes I might do purposive sampling, so there is a subset that I'm looking for, and so I will exclude people for some particular reason. So if I'm interested in, college freshmen, that I'm going to specifically exclude people who are not college freshmen. And then there's quota sampling. If I know that my population is, 15% freshmen, 20% sophomores, and 30% juniors, and 35% seniors. I have no idea if that ended up to 100%, but we'll just pretend like it did. And so I would want my population, to look like that. So I want my sample to look like that. So I want to make sure my sample has those same proportions. So I keep my sample proportionate to what the population looks like. So where do we get our data? Well, we can get it from lots of places. We can go to archives, particularly if we're looking at texts. So I might go to gather those original texts. I might go to the field. I might have to go watch people do stuff in order to gather information. I might simply go to the lab, and the lab is kind of broad. In some instances, it may require you coming to a physical location. Sometimes that's an online survey, right? It's the virtual lab now. Well, how do we decide how to gather our data? Well, how we get there is in terms of measurement, and it starts with how we define things. So we have these conceptual and operational definitions. So sometimes we'll talk about as conceptualization and operationalization. So the conceptual definition is the idea that we have. We want to know something. So this is the theoretical term that we might have. So in this instance, I want to measure how people respond to sweetness and how sweet things are. What does it mean for something to be sweet? Right? We can talk about what conceptually that means, right? It's sweet. It's the absence of bitter. It's not salty. A certain level of sugar content is present, right? So it's sweet, right? We kind of have an idea of what that means. Well, how do I operationalize that? So in other words, how do I put that into action? How does that become usable? And so in this instance, I might ask people to eat an apple slice, right? That's how I would operationalize sweetness. Are there other ways to operationalize sweetness? Yeah, I could give you a cup of sugar and ask you to pound that cup of sugar and see how you responded to sweetness, right? That would be a totally different way of responding to sweetness, but it would still be an operationalization. And so what we want is that if we have a good operationalization and people are measuring the idea the same way, then we can have some consistency across different kinds of observations and make comparisons. So when we get into the measurement, right, the data that we actually gather is going to look a little bit different given the types of measurement that we engage in. We're going to get different types of data. So we're going to go through these 4 different types of data. These are going to be important later on for you to be able to discuss them in terms of your homework assignments, but also it's good to just be able to distinguish among them. So the kind of lowest level of complexity is nominal. This is really just looking at mutually exclusive categories. I think about this as mail sorting, right? If you go to the post office, which box does this go in? Does this go in-state, out-of-state? There's no rhyme or reason as to one being first or second. They're just different, and these are mutually exclusive options. You can't fit into 2 boxes. And if it seems to not work, then you need to come up with a new box. We are just simply sorting things. All right, is this savory? Is this sweet? Which one does it go in? How would we categorize it? So, for instance, biological sex would be one. You'd be male, you'd be female, right? Those are two mutually exclusive options, typically is how we think of it. Just like I would describe something as frozen or not frozen, right? You either are or you are not. That is nominal data. We can then take that idea of sorting things into different boxes and we can rank them. And now we have ordinal data. So this is rank ordered nominal categories. So there is something that is the most. There is something that is the least. So for instance, I can give movie ratings 1 to 5 stars, right? This movie got 5 stars. That movie got 4. 5 is more than 4. How much more? That depends, right? Just like you can think about if someone were in a race. You came in first, you came in second, you came in third. That doesn't tell you how close you were, right? So I could have finished, and then 30 minutes later, second place could have come in. And then 20 minutes after that, third place could have come in, right? That's still first, second, and third. In another race, someone else could have finished within a 0.2 of a second behind me, and then barely a second after that. They're still first, second, third, right? So the distance between first and second can vary. It's just that's the box that you go in. Now, if we want to move to a higher level, we think about interval data. And this is where there is a difference between the categories and ranks, and there is a consistency between the data points. So do I give you a 1, a 2, a 3, a 4, or a 5? The distance between a 1 and a 2 is the same as it is between a 2 and a 3, as it is between a 3 and a 4, and a 4 and a 5, and so on. So we have in some ways standardized the difference. So if I want to compare my first place finish to your first place finish, just based on the ordinal data, I can't. But if we were to do it in an interval fashion, we would be able to do that. Well, so what are the ways that we tend to gather interval data, and how does this sort of make sense to us? The way that this shows up is something called a semantic differential, in which you often find adjective pairs on opposite ends, and I will provide you with an idea or a concept. So for instance, I will ask you to describe ice cream. Is it good or bad? And then you would have the option of kind of where to place on that spectrum of good and bad. I would say sweet, salty. You might put it on the sweet side, right? And so desirable, undesirable, right? And we have different pairs of words that we would compare them to, and then theoretically the distance between those is also the same. The last one is ratio data, and it's simply taking interval data to the next level. If I asked you to rate how much you liked pizza from 1 to 5, that assumes that there is an amount that you do like pizza. And for some reason, you don't at all. So ratio data has a 0 point, whereas interval data does not. So it allows us to make ratios of how much of something that you have. So for instance, if I were to ask you on a scale of 0 to 7, how much do you like pizza? And you put a 0, you like it 0 amount, compared to someone who likes it 7. Right, that's 7's a whole lot more than 0. You have the absence of that preference, and that person has the maximum amount. And so ratio data gives us a little bit more of a comparison point. So those are the types of data that we can gather, and those are some of the broad level terms that are useful for when we think about data.